Your air conditioner is quietly working against you this summer, not because anything is physically broken, but simply because nobody ever showed you how to prepare it properly for the season ahead. The average homeowner turns on their system on the first truly hot day of the year, hears it running, and assumes everything is fine. But that assumption is costing people real money every single month, and the fixes are far simpler than the cooling industry would have you believe. Think about this for a moment. A dirty air filter alone can raise your monthly energy bill by as much as 30%. A clogged condensation drain line can flood your ceiling or floor with zero warning whatsoever. Bent aluminum fins on your outdoor unit gradually choke your airflow until the compressor overworks itself into failure. These are not rare, catastrophic failures that require an expert. They are ordinary, predictable maintenance problems that any homeowner can address at home, often with tools and materials that cost less than $2 in total. In this guide, we are going to walk through 5 complete fixes in real detail. Not a rushed overview, but a thorough, step-by-step understanding of what is happening inside your cooling system, why these problems develop, and exactly what to do about each one. By the time we finish, you will understand your air conditioning system better than most people who have lived with one for decades. The air filter, the most overlooked component in your entire home. Let us start with the single most neglected piece of any central cooling system, the air filter located inside your air handler unit. This is the rectangular panel, usually made of fiberglass or pleated material, that slides into a slot somewhere on your indoor unit or in the return air duct. Most homeowners check it once, forget about it, and then wonder why their electricity bill keeps climbing. The history here is actually interesting. Back in 1952, the engineer Willis Carrier redesigned modern air handler units with a removable filter panel built right into the housing. The concept was elegantly simple. Trap the dust, pollen, and debris before it ever reaches the evaporator coils. If the coils stay clean, the heat exchange process stays efficient, and your system runs the way it was designed to run. It was a genuinely good idea. But Carrier could not have anticipated that millions of homeowners would simply install a filter and then forget it existed entirely. The U.S. Department of Energy published research on this specific issue, and the findings are striking. When a filter becomes clogged with accumulated dust and debris, the blower motor inside your air handler has to work significantly harder to pull air through it. That extra effort translates directly into higher energy consumption, somewhere between 15 and 30% more electricity just to move the same amount of air through a dirty filter compared to a clean one. To put that in practical terms, it is roughly equivalent to running your entire cooling system for an extra phantom room that does not exist anywhere in your house. Now here is the part that most people have never been told. You do not necessarily need to buy a brand new replacement filter every 3 months. The filter replacement market in the United States alone generates enormous revenue precisely because manufacturers and retailers have no incentive to tell you that many standard fiberglass filters can be cleaned effectively at home. The method is straightforward. Fill a bucket or a large sink basin with warm water and add approximately 1 cup of plain white vinegar. Submerge the filter completely and allow it to soak for 30 minutes. The acetic acid in the vinegar breaks down the trapped particles and dissolves the biofilm that accumulates on filter fibers over time. After soaking, rinse the filter thoroughly under running water until the water runs completely clear. Then, and this step is critical, allow the filter to dry fully and completely before reinstalling it. A damp filter reinstalled into a running system is worse than a dirty one because moisture inside your air handler creates the exact conditions where mold and bacteria thrive. Replacement cartridges typically sell for $15 to $20 per unit every 3 months. That adds up to roughly $80 per year per unit. If you have 2 units in your home, that is $160 annually just on filters. The vinegar cleaning approach costs you a few cents and about 40 minutes of your time. Both methods achieve the same result: a clean filter that allows your system to breathe properly. Do this at the start of every cooling season, and again at the midpoint if your system runs heavily. It is the single highest return maintenance task available to any homeowner. Walk outside to the large metal cabinet sitting on a concrete pad near your home's exterior wall. This is the condenser unit, and it is the component that releases all the heat your indoor system pulls out of your living space. The refrigerant flowing through this unit arrives hot, releases its heat to the outside air, and then returns indoors to absorb more. The whole process depends on adequate, unobstructed airflow moving through those thin aluminum fins that surround the exterior of the unit. Those fins are extraordinarily thin, sometimes barely thicker than a sheet of aluminum foil, and they bend very easily. Lawnmower debris, hailstones, children playing nearby, animals brushing against the unit. Even just the steady vibration of the compressor over years can cause dozens or hundreds of individual fins to bend and flatten against each other. When that happens, the spaces between them close off, airflow through the coil is restricted, and your system loses a significant portion of its ability to shed heat. Research from the University of Illinois examining residential cooling systems in controlled laboratory conditions found that blocked condenser fins reduced overall cooling efficiency by approximately 19%. That is nearly a fifth of your entire summer cooling capacity simply wasted because of bent aluminum that a $2 tool could have straightened in 10 minutes. That tool is called a fin comb. It is a simple piece of rigid plastic or metal with a series of teeth sized to match the fin spacing on standard residential condenser units. You insert the comb into the fins at an angle and draw it upward, and it straightens bent fins back to their proper position as it moves through them. HVAC service technicians carry these in their toolkits and use them on every seasonal maintenance visit. The comb itself costs under $2 at any hardware store or online. Before you begin working on the condenser unit, always turn off the power at the disconnect box mounted on the wall near the unit. This is usually a gray box with a pull-out block or a large switch. Pull it out or switch it off completely before touching anything. Once power is off, use your garden hose to rinse the fins from the inside of the unit outward. This is important. Spray from inside out so that debris is pushed away from the coil rather than deeper into it. Many homeowners do the opposite, hosing the outside and driving compacted dirt further into the fins. After rinsing, work through any visibly bent sections with the fin comb. You do not need to straighten every single fin perfectly. Just getting them open enough to restore airflow is what matters. Allow the unit to dry completely before reconnecting power. While you're out there, clear away any vegetation, debris, or obstructions within at least 2 feet of the unit on all sides. Shrubs that have grown close to the condenser, stacked items leaned against it, or thick vine growth on the unit can restrict the airflow just as effectively as bent fins. The condenser needs clear space to breathe. This entire process takes about 15 to 20 minutes and significantly extends the life of your compressor, which is by far the most expensive component in the entire system. The condensation drain, the silent flood risk. Every homeowner ignores. Here is a problem that virtually no one thinks about until it causes real damage, sometimes catastrophic damage, to their home. Every air conditioner produces water. As warm, humid indoor air passes over the cold evaporator coil inside your air handler, moisture condenses out of the air just like droplets form on a cold glass on a humid day. That condensation drips into a collection pan beneath the coil, and from there it flows out through a narrow PVC drain line, typically exiting somewhere near the outdoor unit or into a floor drain. Under normal operating conditions, this system works perfectly. The problem is what happens during the months when your cooling system sits idle. In the warm, dark, moist environment of a drain pan and drain line, mold colonies establish themselves. Algae and biofilm grow along the interior walls of the drain tube. By the time you switch your system on in late spring after months of inactivity, the drain line may already be partially or fully blocked. When that happens, the condensation has nowhere to go. The collection pan fills up and then overflows. Depending on where your air handler is located, in a utility closet, in an attic, or in a ceiling space, that overflowing water can cause serious structural damage, destroy drywall, ruin flooring, and create widespread mold contamination throughout your home. Water damage repairs from a single overflow event can run into thousands of dollars, not counting the cost of mold remediation if the problem goes undetected for any length of time. The preventive treatment costs less than 50 cents and takes about 2 minutes. Locate the condensation drain access port on your indoor unit. It is usually a small, capped opening on top of or near the drain pan, often with a white PVC cap that lifts or unscrews. Remove the cap, pour 1 full cup of plain white vinegar directly into the opening, and let it sit undisturbed for 30 minutes. The acetic acid works its way through the drain line, dissolving biofilm and killing the mold colonies that have formed during the off-season. After 30 minutes, flush the line with clean water and then go check the outdoor termination point of the drain line to confirm that water is flowing freely out the other end. Research by microbiologist Dr. Charles Gerba at the University of Arizona has demonstrated that ordinary household vinegar eliminates a very high percentage of surface mold and bacteria. It is not a harsh industrial chemical, it does not damage PVC plumbing, and it does not require any protective equipment to use. It is simply effective. Do this at the beginning of every cooling season as a preventive measure. If you want added protection, you can also drop a few algae prevention tablets, available in HVS supply stores for $1 or $2, into the drain pan after flushing. These tablets release a slow-acting treatment throughout the season that keeps algae from reestablishing. This is the easiest form of insurance your home has available to it. The thermostat. The free fix that most people never use. The thermostat is the smallest component in your entire cooling system, but it exercises complete control over everything else. And the way most people use it is genuinely hurting their energy bills in ways that are entirely unnecessary. On the first hot day of the season, the instinct for most people is to crank the thermostat as low as it will go. You want immediate relief, so you set it to the coldest available temperature and walk away. The problem is that this causes the compressor to run at maximum capacity and never cycle off. The system runs continuously, working as hard as it possibly can, trying to reach a temperature that the house may not even be capable of holding during peak afternoon heat. The Department of Energy conducted testing across hundreds of real households and found that for every single degree you raise your thermostat setting above a very cold baseline, you save approximately 3% on your total cooling cost. The math here is simple and significant. Setting your thermostat to 24 degrees Celsius rather than 18 degrees saves roughly 18% on your cooling bill over the course of an entire summer. On a significant electricity bill, that is a meaningful amount of real money saved purely through a free adjustment. The key insight is that your body is more adaptable than you think. Most people who experience cooling discomfort are not reacting to the actual temperature in the room. They are reacting to the difference between the outdoor heat and whatever temperature they walk into. If you arrive home after being in 38-degree heat, stepping into a 24-degree room feels dramatically cooler than the number suggests, because the contrast is so large. A practical approach for transitioning into the season: start at 24 degrees Celsius on your first day of running the system. Leave it there for the full day and allow your body to settle into it. The following day, lower it by 1 degree if you need to. Continue this gradual adjustment until you find the temperature where you feel genuinely comfortable. Most households find that they settle comfortably at 22 degrees, which is still 2 full degrees higher than the 24-degree starting point that already saves 18% compared to extreme settings. 2 additional thermostat practices are worth building into your routine. First, program your system to run a few degrees warmer during hours when the house is empty. If everyone is at work or school for 8 hours each day, there is no reason to cool in an occupied house to the same level as when people are present. A programmable or smart thermostat can automate this completely. Second, avoid the temptation to use a lower setting as a way to cool the house faster. Your air conditioner does not cool faster when set lower. It cools at the same rate regardless of the setting. A lower target simply means the compressor runs longer. Air sealing, the fix that amplifies everything else. Every efficiency improvement you make to your cooling system, cleaner filter, straighter fins, clear drain lines, optimized thermostat settings, is undermined if your cooled air is leaking out of the building. Air sealing is the final and often most impactful piece of the efficiency puzzle, and like everything else in this guide, it costs almost nothing to address. Foam weather stripping tape is available at any hardware store. A full roll typically costs under $2 and covers multiple window or door frames. The tape has a peel and stick adhesive on one side and a compressible foam material on the other. You press it along the edges of window frames, door frames, and anywhere else you suspect air is escaping, and it creates a soft seal that closes off the gap. But before you apply anything, you need to find where the leaks actually are. Here's a simple diagnostic method that requires only a stick of incense or a candle. Light it and hold it near the edges of window frames, particularly around window-mounted air conditioning units, which are notoriously poor at sealing against the frame they sit in. Watch the smoke carefully. If it drifts consistently toward the exterior, but being pulled through the gap and out, you have found a leak. Mark those spots and apply your foam tape. The Department of Energy's Weatherization Assistance Program has documented that air sealing alone can reduce cooling losses through leakage by between 25 and 40%. Think about what that means in combination with everything else in this guide. A clean filter restores your system's airflow efficiency. Straightened fins restore your condenser's heat shedding capacity. A clear drain line protects your home from water damage. An optimized thermostat setting reduces how long the compressor runs. And proper air sealing means that the cooled air your system generates actually stays inside the building where it belongs, rather than slowly bleeding out through gaps in your windows and doors. These 5 things working together represent the complete picture of home cooling maintenance at the basic level. None of them require professional tools, technical certification, or anything more than a few basic household materials and a couple of hours of your time at the beginning of the season. Here is the complete sequence for preparing your cooling system before you turn it on for the season. Step 1, clean the air filter. Remove it from the air handler. Soak it in warm water with 1 cup of white vinegar for 30 minutes. Rinse thoroughly. Dry completely. Reinstall only when fully dry. Step 2, service the outdoor condenser unit. Turn off power at the disconnect box. Hose down the fins from inside the unit outward. Straighten any bent fins with a $2 fin comb. Clear all vegetation and debris from around the unit. Reconnect power only after the unit has dried. Step 3, flush the condensation drain line. Locate the access port near your indoor unit. Pour 1 cup of white vinegar into the opening. Wait 30 minutes. Flush with clean water. Verify flow at the outdoor exit point. Step 4, set your thermostat strategically. Begin the season at 24 degrees Celsius. Adjust downward by 1 degree per day until you reach your comfort level. Avoid extreme cold settings that keep the compressor running nonstop. If you have a programmable thermostat, set it to a warmer temperature during unoccupied hours. Step 5. Find and seal air leaks. Use an incense stick to identify gaps around window frames, door seals, and AC unit penetrations. Apply foam weather stripping tape wherever you detect outward air movement. Conclusion. Your grandparents maintained their own window units every season without hiring anyone. They cleaned filters with soap and water, straightened fins by hand, poured vinegar down drains, and stuffed cloth strips around window gaps to keep the cold air in. That accumulated practical knowledge represented generations of homeowners who understood the machines in their own homes. None of what we have covered today is complicated. None of it requires special skills. The materials cost almost nothing. What it does require is awareness, knowing that these systems exist, knowing what they do, and knowing what to do when they need attention. A professional HVAC seasonal tune-up typically costs between $150 and $250. The 5 steps in this guide, done thoroughly with basic household materials, address the same core maintenance items that technicians check during those visits. The difference is not expertise. The difference is simply access to information. And now you have it.